Hello everyone, welcome to my channel strongmath. Today we'll discuss about some methods of integration. In this video, we'll discuss about the method of integration by substitution. At first, we'll discuss the method of this type of integration, and then what are the procedures to solve the problems related to integration by using this method, and then we'll discuss some simple problems related to this section of integration. If you want to learn integration, then you must watch our previous video related to basic concepts on indefinite integral and their formula. We have already discussed some problems related to indefinite integral. Now here, those functions which are not readily obtainable from derivatives of some functions need some technique or finding the integrals by reducing them into standard form. That is, by using the basic formula, sometimes we cannot determine the value of the integration. For those cases, we have to apply some technique. There are three methods of finding their integrals. Number 1, integration by substitution. Number 2, integration using partial fractions. Number 3, integration by parts. In this video, we will discuss about integration by substitution. What is the procedure to find out the value of the integration? The given integral, integration fx dx, can be transformed into another form by changing the independent variable x to t by substituting x equals to function of t, that is g of t. Now let us consider I equals to integration fx dx, that is the given integral is chosen as I. Now put x equals to function of t, that is g of t, so that dx dt is equals to g dash t. You have to remember, we have to take a function of x as function of t, so that dx dt is equals to derivative of that function of the variable t. Now we write dx equals to g dash t dt. Thus the integral I becomes integration fx dx is equals to integration f of g of t into g dash t dt. Now you must remember these three rules. In the above discussed change of variable formula is one of the important tools available to us in the name of integration by substitution. Number 2, it is important to guess what will be the useful substitution. You have to guess what to substitute. Usually we make a substitution for a function whose derivative also occurs in the integrand. That is, we have to choose a function as another function so that that function's derivative must be present in that integrand. Now let's do some problems. Then you can easily understand what is the procedure of integration by substitution. Number 1, integration 2x sine of x square plus 1 dx, and number 2, integration sine of tan inverse x upon 1 plus x square dx. So as we have already discussed that we have to substitute a function of independent variable whose derivative is already present at the integrand. Now there are two functions, sine function, sine of x square plus 1, another one is 2x. So now if we choose x square plus 1 as t, then its derivative is 2x, which is already present here, present in the integrand. So if we put x square plus 1 equals to t, then derivative of x square plus t is 2x dx, which is already present in the integrand, which is equals to dt. So we can write it in the form of the variable t, that is 2x into dx gives us dt, and sine of x square plus 1 gives us sin t. So sin t dt. Now integration sin t dt gives us the result minus cos t plus c. In the next step, we have to substitute the value of t. What is the value of t? T is x square plus 1. So we have to put x square plus 1 in the place of t. So this is cos of x square plus 1 plus c. Now for the second problem, sine of tan inverse x by 1 plus x square dx. We have to assume some function as t. Now it is now clear that what to substitute. We have to substitute tan inverse x is equals to t, as derivative of tan inverse x is 1 upon 1 plus x square, which is already present here, into dx is equals to dt. So if we substitute this one, then we will get sin t dt, as sin tan inverse x is t, so sin t, and dx upon 1 plus x square gives us dt. So again this will be cos t plus c, which is equals to minus cos of tan inverse x plus c. Look at the I button. I have already given the link of the video in which you can easily understand the basic concept and the basic formulas related to integration. Now let's discuss some more formula related to integration. In the first formula you have integration tan x dx, which is equals to log mod sec x plus c. In the second formula you have integration cot x dx, which is equals to log mod sin x plus c. In the third one, integration sec x dx is equals to log mod sec x plus tan x plus c. And in the fourth one, integration cosec x dx is equals to log mod cosec x minus cot x plus c. Let's apply these formulae. Let's discuss about two problems. The problems number 3 and 4 you can see on your screen. For the first problem, that is integration dx by 1 plus tan x, at first let's break tan x into sin x cos x. So this will gives us cos x dx by sin x plus cos x. We have to adjust the numerator as half into 2 cos x dx by sin x plus cos x. Now rewrite the numerator as cos x plus sin x plus cos x minus sin x divided by cos x plus sin x into dx. Now this equals to, if we separate them, we will get half integration dx as cos x plus sin x by cos x plus sin x 1 plus half into integration cos x minus sin x divided by cos x plus sin x into dx. Integration dx is x, so this is x by 2 plus half into, now look, if we take cos x plus sin x as t, then derivative of cos x is minus sin x, derivative of sin x is cos x into dx is equals to dt, which is already present in the numerator. So we can write the integrand as integration dt by t, which is equals to x by 2 plus integration dt by t is log t, so half log t plus c. C is the integrating constant. Now substituting the value of t here, we get the final answer, that is x by 2 plus half of log of sin x plus cos x plus c. At first, write sin x in the form of sin of x plus a minus a divided by sin of x plus a dx. Now we can apply the formula sin of a minus b, which is equals to sin a cos b minus cos a sin b. So we get integration sin of x plus a into cos a minus cos of x plus a into sin a divided by sin of x plus a dx. Next step, let's separate them. Then we will get integration cos of a dx minus sin of a into cos of x plus a by sin of x plus a dx. As cos a and sin a are independent of x, hence in this case they are constant. So cos of a integration dx minus sin of a integration cos of x plus a by sin of x plus a. Let's put sin of x plus a equals to z for the second integral. Then we get dz equals to cos of x plus a into dx. Substituting this, we get cos of a integration dx minus sin of a integration dz by z. We know that integration dz by z equals to log z. So in the next line we get cos of a into x, that is integration of dx equals to x, minus sin of a into log z plus c, where c is the integrating constant. After substituting the value of z, we get the final answer. So the final answer is x cos a minus sin a log mod sin of x plus a plus c. Thanks for watching this video. Please like, share and comment, and obviously please do subscribe my channel Strong Math. Mention your query. Keep watching. Thank you.